So now we have Anthony Marasco and Jesse Allison from Louisiana State University as well. And their presentation is Connecting Web Audio to Cyber-Hacked Instruments in Performance.
Anthony Marasco, and this is my colleague Jesse Allison. We are also from Louisiana State University, the Experimental Music and Digital Media Department. And we're going to talk to you about connecting web audio to cyber-hacked instruments in performance. This adventure is kind of something that we both collaborated on over the last 9 months or so, merging our two different research fields together for a unique purpose, which we'll talk about in a moment. So overall, we're going to talk about kind of cursory introduction to these two different practices that we merged together. Hardware hacking for music, also known as circuit bending. And then we're going to talk a bit about networked musical performance, which most of you probably here at the Web Audio Conference have experienced or done your own research and composition in as well. We're then going to talk about the goal of our project and what we succeeded at. I believe we did, at expanding the NMP device set. So expanding the amount of devices you can use for network musical performances. And by doing so, by incorporating new devices, by cyber hacking them. We're also going to, along the way, talk about the two frameworks we used to, that keeps happening, to get that to work. Nexus Hub, which is a server-based framework that Jesse created, and Bend.io, which is my side of things on the hardware and cyber hacking elements. And then we're going to talk about composing with this system. Then we're going to talk a little bit, I'll give you a preview of a piece we're going to do tonight at the concert that you'll get to experience and participate in later. So to start off, let's talk a little bit about hardware hacking. So like I mentioned, this is also known as circuit bending. This is the broad act of subverting a piece of hardware for audio or visual, I'll say, or in this case for us, musical exploration. It is an exploratory act. Basically what you're doing is taking a device that has the capability of making sound and opening it up and probing different points along the internal circuitry and connecting it to other points. And hopefully nothing explodes or catches fire. And if it doesn't, you'll hopefully get some cool sounds. And you're kind of pushing the limitations of this device in a couple different ways, both aesthetically and sonically. So some common objects people have circuit bent in the past, you can see, it's over my left, things like a speak and spell, done here by A.J. Gannon. There's been a ton of academic research on the subject of hardware hacking for music done by people like Nicholas Collins and Reed Ghazala as well. The interesting thing here, too, is there's a big risk-reward balance in this act. Like I mentioned, you are always at the risk of breaking the device that you're trying to hack, but you're also going to hopefully get some kind of interesting reward by making the audience see a toy or a media player in a brand new light. And you're also rewarding yourself as a performer by finding a new way to interact with this object, as you can see by like the added strumming paddles and whammy bars to supplant buttons on a speak and spell. I do want to show you some quick examples if you've never seen this stuff in action. So this is a piece by Nick Collins called The Royal Touch. And what he does in this piece is take a circuit board, usually I think it's like an audio amplifier or receiver board, and he's built his own circuit that branches out on cable and fishing weights, little metal contact points that sends voltages out, and you can kind of move this nest of electrical dissemination across the circuit board. And by connecting these disparate points, he's kind of waking up components on the board to create random oscillations and different kind of frequency patterns to create some really sort of chaotic ambient sounds. Get this to play here. Oh, do we have audio? I'm on the decimator. Is that the right one? Very foreboding title for a HG minor interface. Anything? Do we have audio? We should be all good and selected here. Yeah, it's a decimator, the very scary one. You want me to play it again? Let's hope it works. Yep. We can go to the next one. I mean, you hear some very Cool sounds there. The next one here. Oh, come on. Can we get the audio working? Because the next one's going to be even better. It's going to be so good. It's a Furby organ. I'll talk a little bit what I wanted to show with the last example. Oh, I'll kind of buy some time. Maybe we can get the sound working for this. With the last example, that's a very classic example of circuit bending, right? You're taking an object, you're enacting upon it in a new and creative way. It also shows some of the limitations of circuit bending as an art form. You have to usually be there at the device. It is usually a very tactile device. So if you're not moving those connections through like a nest of wires, you're engaging those bend points through like a button or changing resistance levels through a dial. So it's very one-to-one, very physical, right? Good and maybe some bad points about that too. Take example, a less conventional option of circuit bending, the Furby organ by Sam Battle. No, oh. Decimator. What are you doing? Okay, well, you hear a very nightmare-inducing clip of 26 Furbies screaming in pitch and broken out to a keyboard interface. So the goal with this example of circuit bending is to move a little bit closer to what we do in network musical performances already. You've got an interface that's mediating the performance. You're not flipping a switch on each of these Furby, I guess, individually, and you're not really kind of worried about the chaotic aspects. You plan this all out and you've kind of moved it into something traditional, like a keyboard interface. But this would be hard to do with one person and two hands, right? 26 Furbies and bending these different points together. So breaking it out to some kind of mediated element between you, the performer, and the devices, this kind of set me off on what is now my dissertation research, which is finding a way to take hardware and to move it closer to being glorious. Very cool. Drum machine not included, right? I told you it was horrifying, right? But so this leads us into the NMP side of things. I'm going to turn this over to Jesse to tell you a bit more about that realm of research to add on to this.
I've got a mic. Okay. So just as you all know, basically the network musical performance has been a focus of the Web Audio Conference since the very beginning. This happens to be the first performance at the first Web Audio Conference, and it was entirely network musical performance. And it's been just a wonderful space. So I'm not going to belabor this, but just kind of walk through a couple things about it. That whole distributed performance types of things where you're connecting many people to each other, devices to devices, all that kind of thing. The fact that it can be very abstract, for instance, people's phones just performing across the space, or something where you can actually touch and control, or it can be actually devices and things, and we'll talk about that in a second. The other is that it's mediated, which I think is pretty interesting, and something that I like to kind of work with. It's that anything that sends into the system can control anything else, or it can control many other things, or you can have any of the other inputs, right? Aggregated, changed, mediated, and then controlling one thing or many other things, right? And the thing that's interesting about this, and I think that Anne doesn't do justice to, is that every one of those inputs has meaning, right? Whether it's a touch, a swipe, or some control, or perhaps it's some dancer, or some graphic, or some video tracking, or whatever these inputs are into this system can now be mapped. And the meaning from each of those inputs can now be mapped to the meaning of the other things that are being triggered and manipulated. And we'll see that in a second. But the way that that works is kind of aggregating around these the Internet of Things ideas, right? The Internet of musical things, or the orchestra things, or that sort of stuff, where we're changing. We're basically just using it for musical purposes, right? NMP. And so I just wanted to bring up this example from my work. Kind of works in this hybrid worlds realm. where you're trying to bridge things from virtual worlds into the real world and back and forth. And virtual worlds is very broad. It's not just video games, it's not Second Life, it's whatever. It could be anything, internet, social media, whatever kind of system that might be. But bridging between the real world and the other. This is a series of pieces. This first one here is actually a piece that has, you can see it down in the bottom corner, is actually a projection of Second Life, where in that virtual world, people could come in from anywhere and then play with this structure, and then anytime there were interactions with the structure, it actually played music on the organ, right? So we captured information from this virtual world performance, we played it on the organ, piped that back into the virtual world so people could have either virtual or in the same space interactions. And that series of events has been played across many things. We did one where we connected the carillon in a bell tower, which we were controlling, to the Finial Hall, the Bell and Finial Hall for Boston Cyber Arts. We did another one where I had the audience on cell phones all controlling an organ instead of using Second Life. Skipped that entirely, and did something at the Seamus conference 2014. But the idea that anything can control anything else and that you can have these meanings behind each one of those pieces is pretty interesting. So the way that I've been working with this for the last 10 years is through various web app technologies, right? Being able to disperse things, pass things around. The cloud, the server, being able to be a mediator between all the different systems you want to connect, whether it's people with cell phones, projection on the theater, audio into multi-channel speakers, whatever that system is, right? But the idea here, and the thing that's kind of interesting, is that once you have all these networked devices, you can end up controlling it and mediating stuff. But there's a lot of things that aren't networked. And it gets really interesting when you start thinking about the things that aren't networked that you might be able to bring into that network.
Right. So that kind of was where I joined in and kind of pushed with this with my dissertation work as well, is taking a device and trying to find the goal of having any device as a networkable device that we can work on to the web audio realm or the NMP kind of aspect. So if you're talking about like an organ or a carillon, which is designed to work acoustically and then adds like something like MIDI I/O, now if we could take a CD player or a toy or a Walkman or a record player or a toaster or whatever you have, and kind of push that exploratory, experimental side that we're already doing in circuit bending, and then add in some kind of intermediary circuit so that now it's networked, and those actions that were physical, like a button or a dial, are now aka remote or also mediated. So you're adding some new meaning to that too. And hopefully the goal here is to extend the devices we use in NMP. We use mobile phones and mobile devices like tablets a lot for obvious reasons. They're ubiquitous computing devices. But now we can add new things into that realm too. So what we've done here is take Jesse's work with Nexus Hub and kind of bring it over to my work with this framework called Bended.io. And this kind of diagram here just kind of shows the idea you're taking the top part, which is traditional NMP, and now adding that in with multiple devices. The way we do this is with a hardware solution that I created here called the Bended.io board. This has got an ESP32 microcontroller in the upper left-hand corner there. It adds on some 6 reed relays, which simulate a button press connecting point A to point B. You've got 6-channel digital potentiometer to simulate physical resistance or voltage division changes. A 2-channel motor driver to enact solenoids to push down tape heads or run a motor like in a record player. It also has onboard ADCs and DACs, which the ones that are on this first version of the board are a little lower resolution than we'd like. So I'm adding a second kind of expandable option for the new version of the board. So you can do some circuit sampling or some voltage sampling and send it back into the device and send it up to control shaders or something digital or visual. So we want to talk a little bit to close out here about composing with this system and give you a preview of what you'll experience tonight. So the piece we designed, Gravity Density, has two hardware hacked, or cyber hacked, I should say, CD players. This is based on research people like Nicholas Collins did with CD players in the early 80s, and also users like R229, who worked with CD players to control the playback features, which I'm doing here, as well as breaking the internal muting. So when we pause the CD players now, you're actually hearing rhythmic loops from the same sample being read by the laser as the disk continues to spin. And I'm also bridging some of the internal anti-skip memory chips, or pins on those chips, so you can get some data moshing happening with some of the samples that are being recorded into its internal buffer. And we've also added in a distortion pedal, because why not? And so what we're doing tonight is doing a lot of things with the CD players as source audio, and then feeding that out to you, and then having you sample some things, and we can kind of filter everything we want through the distortion pedal and change the intensity of the distortion through mediated means.
So very briefly, basically the audience hall has their own interface for this. And then because we have a number of different sources, we basically kind of structured the piece so that it exposes different things at different times so we don't kind of overwhelm. People can sample things, the process stuff individually. There's the bent CD players, things being fed into the distortion pedal, and it's just kind of meted out over time. And then I have kind of a controller interface to make sure everything's going the way that I hope it's going. So anyway, you will see that and perform in that tonight. Make sure your phones are all charged up.
Yeah, and I'll add before we wrap up here too that if you're interested in working with some of these bended boards coupled with the Nexus Hub software for your own maker spaces and want to experiment with your students or yourselves with circuit bending, just come and talk to us or email us here, because we'll be have the ability to send some boards out to be used in user studies and things like that. So thank you for your time.
Brilliant. Thank you very much. We have time for some questions. Are there any in the audience? I haven't been able to connect to the Slack channel yet, but I'm not sure if anyone is using it. We have a question up there.
Thank you. You talked about the way that meaning is involved in the gestures or the interactions. I just would like you to go into that in a bit more detail, what you mean by meaning.
I mean, this could be all sorts of stuff. I think that the same way that you can be a music artist or you can be a visual artist, you can also be an interactivity artist, or somebody who makes art out of interactions. And I think that when you think of, playing a keyboard, that's one type of dynamic, but also walking through a space, if you're tracking where someone was walking, and if they were walking from one thing to another, each of those places has meaning. And so that path itself has its own meaning, right? And so by using things and actually thinking about what the interactions and the motions and the gestures and whatever it is that you're doing, the meanings that are inherent in that, you can actually bring that into your artwork, or you can ignore it. And I think that a lot of times that's just what we do, is just ignore it. But
yeah, and adding to that on the hardware side of things, an aspect today that I think makes circuit bending still popular is there's a nostalgia connection. So even if you're too old to know how a CD player worked or why we clip these to our belts, you kind of get the idea that it's older tech and there's maybe an interest, or the idea of also upcycling these things and saving them from a landfill and repurposing them for artistic purposes. Now you can couple that with the many different aspects of meaning of how you actually enable these things or enact these things. I think there's a room to kind of explore that concept on all fronts here.
We have time for one more question.
Thanks for the presentation. Is Bandit.io like an open source, open hardware project?
Not yet, no. I hope in the future it will be. But what I'm doing right now is working on, I've got a ton of these version 1 boards that I realized I wanted to add more features onto. Right now I'm building the second version, which I'm hoping, like I said, if anyone's interested in either version to use, to kind of add expandability to it. But the goal is to kind of get it ready so that there's tons of user examples for how to connect this to that. And then in the future, I'd like to try and make it more open source.
He has to finish his dissertation first.
Yeah, I got to have to finish that first, and then we can do it. Yeah, but if you're interested in any of that, please come talk to us. Love to tell you about it.
Brilliant. Thank you, Anthony and
Thank you.
Jesse, for the brilliant presentation.